Hi everyone. In the previous session, I have shown you some program where the lex and yak programs are combined together to solve a problem. The problem was to recognize a variable. So the variable it should start from the letter and it should continue with either letter or the digits. We can use the underscore also. So in that problem, we have used the lex program and yak program. So in the lex, we were using the pattern to identify the letters, alphabets, numbers, and underscore. Whereas in the yak program, there was a grammar which is used to identify whether the given identifier is starting with the letter followed by either the letter or digits or the underscore. So this is what program I have explained you in the previous session. Now we'll move on to the next topic, precedence and association. So in what way the precedent and association is related to the program lex and yak program is when any expression is given. So when you evaluate an expression, you have to follow certain precedence rules and associativity rule. So for example, if you consider 1 minus 2 minus 3, the first example is given here, 1 minus 2 minus 3. So in 1 minus 2 minus 3, so there is a doubt, there is a dilemma whether to choose 1 minus then minus 3 or 1 minus then we have 2 minus 3. So this dilemma would be there, and if you follow the associativity rule, we can go always with the left association. So we'll be starting with 1 minus 2, then minus 3. The second situation where you have the example, the expression as 1 minus 2 into 3. So in this, in general, according to the associativity rule and the precedent rules, we knew that the multiplication is having higher precedence than the minus symbol, so the subtraction. So that what we'll do, we perform 2 into 3, then we do the subtraction. So that is what 1 minus 2 into 3. So the 2 into 3 will be done first, then we go with the subtraction. As you know, the multiplication has higher precedence. In the previous case, we go with the associativity rule. So as we knew that there is a precedence rules and associativity rule to be followed when you evaluate the expressions, we have to follow in such way. But in the program, we have not given so far any such kind of condition, so that how the program, yak program is going to handle in this kind of situation. That's where we use the keywords percentage right, percentage left. So using these keywords, we have mentioned to instruct the yak program to follow the associativity and also the precedence. And when you have this percentage left, therein we have the operators like plus and minus, and we have the percentage left. With that, we have the operator multiplication and division. So why we are not giving the percentage left in the same line, all the operators plus, minus, multiplication and division? The reason is multiplication and division have a higher priority than plus and minus. So if you look at the arrow is going down, so which represent highest priority. So whatever is coming in the bottom, which is having the highest precedence than the others. So this information has to be instructed to the yak program, so that if at all there is an expression, when it has to be evaluated, so it has to do accordingly as per the rules given. So let me consider one example over here. In the YARC program, we have percentage left again with the different operators, and percentage non-associative. So this non-associative, which is meant for unary minus operator. So there is no associativity rule for the unary minus. Now, if you look at the rules part, the grammar, we have expr plus expr. So in the action part, $1 plus $3. Similarly, expr minus expr, then expr multiplication expr division expr, wherein in the action part, if the $3 equal to 0, so in the denominator we have 0, then the error function will be called. So saying that divide by 0 error. If not, then $1 divided by $3. And if you look at the last grammar, if you have the minus, unary minus, then the precedence will be given as a higher precedence to the unary minus, and $, is equal to minus $2. So this grammar will be used to calculate the arithmetic, to evaluate the expression which perform arithmetic operations, addition, subtraction, multiplication, and division. So let me give you one program where it performs simple calculator. So the simple arithmetic operation which will be performed using the YARC program. Let me show you the program. So this program is meant for evaluate an expression involving the operators plus, minus, multiplication, and divisions. Otherwise, we can say that this program is to perform a simple calculator. Now, if you look at the lex part, as I already told you, we have to include the y.tab.h. Apart from that, we have one more declaration, which is externint yyLval. So yyLval, which is used to get the value of the token. So in order to evaluate the expression, so what is there in the expression that needs to be evaluated. So in the expressions, we have operand and operators. What is the operand value that we are supposed to get it? To get the value, we use this yyLval. So it is a external variable. And if you see the rules part in lex program 0 to 9 plus, so we have the integer, since we are using the for arithmetic operation, so we use the 0 to 9, that is for integer. And yyLval is equal to a to I yy text. So here, when you match the pattern, so the pattern will be in a character format. So as I told you already, yy text is a character array which needs to be converted into integer, and that value has to be stored in the yyLval. Okay. So that is where yyLval is equal to a to I, that's a function which needs to convert the ASCII to integer, which needs to be converted as nothing but the matched pattern that will be there in the yy text. Then we return the token as num. And the other pattern is dot. If there is a dot, it will return the first character. Now we'll move on to the YARC program. In the YARC program, we have percentage open and percentage close, in which the stdio.h file has to be included, and there is only one token is included here. So we define that token, percentage token num. And we have the left associativity rule. So percentage left plus minus percentage left, multiplication and division. And we use the non-associative rule for the unary minus. So these informations would be available in the definition section. If you look at the rules part, so in the rules part we have the first grammar. The expression is valid means, so it will be displayed, and it displays the value also. The result and value will be displayed. So val colon exp. So in that case, the action would be it's printing the valid expression and with the value. So the value stored in the $1 represent exp. So in the right hand side of the rule, we have $I. So $I can be $1, $2, $3, $4, and so on. So what is the ith symbol value that is stored in the $I? So here $1, which is representing exp. So that exp we are getting from the previous expressions. If you look at the next grammar, it is for addition, then subtraction, multiplication, and we have for the parenthesis also. So if at all you have parenthesis, the inside the term will be taken. And you have the num token. So if there is a num, $$ is equal to $1. And if there is a operation called division, that time $3 has to be checked for 0. If so, then it has to say that it's an error. We cannot do the division. So it will be displaying the error message. If not, it will do the division part. In the unary operator, so we assign the unary operator here. So in main function, we have the printf statement. So what is the expression we are supposed to enter? Before the YY parts, whatever you want to display, that whatever the message you want to communicate to the user, that you can keep it before the YY parts. So after YY parts, whatever the result comes, that will be displayed. So YY parts in turn will call the YYLex function, and in YYLex function, it accepts the number, and the number will be converted into the integer form because it takes character. It will be converted into integer form, and that token will be returned. So that token we receive from the grammar, and that will be reduced to exp. So when you pass the expression as an input to this program, say for example, let us consider one example. So this is an example. So when you do this way, so what will happen? The number 12 will be considered as a first input, and that will be taken care by the pattern in lex, and it returns the token. So when it is returning the token, we have exp. So the number will be replaced by exp. So the 12 will be converted into exp. And we have the parenthesis. So when the parenthesis comes, then that has to be given a priority. So whatever inside, that will be taken. So 12 divided by 3. So it will be taking the first 12. Then it will be recognized as a num. Then we have the exp. Then /3, it's again num. Then it is considered as a exp. So exp/exp, that will become again exp. So when and where as when the expression is reduced, the corresponding action will be taken place. So 12 by 3, then it will become 4. Then we have the 12 into 4, so it will become 48. So this exp into exp, that will also can happen. Then we have /4, that will perform the operation, and the unary minus will be considered. Then it performs with the unary minus all the operations. So this is how then finally we'll be getting the result as 12. So this has to be done. So the unary minus will be given first priority to consider for the number, consider as number, and that will become exp again. So exp with the another exp, it will be performing the operation, whether it is a plus or minus, that operation will be considered. So this is how the entire program will be doing the operation, so that it will perform the simple calculator program. So let me go back to the slide, wherein the same set of grammar which I have shown in the program, and it does the operation. So when you handle the shift and reduce, there must be some conflicts. When during the shifting and reducing, in the example, when I was explaining about the shift and reduce, in some place I have told you that this should not be reduced, instead it has to be as it is. I think you remember when there is a name equal to exp. So during that time, I was telling you that so the name is equal to exp should not be converted into stmt. If it is converted into stmt, what will happen is this once it became stmt, then afterwards whatever the input comes, that cannot be converted into exp again. That's a problem we face. So accordingly, what is the next? So that is the reason Yak always look ahead for a next token. So when it is looking ahead for the next token, it could understand that there is a one more input will be there, so that it is able to reduce the grammar with that input also. So in that case, it keeps shifting the token into the stack. So in some situation, when the parser is not able to choose whether it has to be shifted or reduced, the shift reduce conflict comes when a grammar is written in such a way that the decision between shifting and reducing cannot be made. So in that case, to resolve the situation, the Yak will always choose to shift. So it will be keep shifting the token into the stack. When the situation arises, then it will be reducing, it will match with the grammar, and it reduce the token. So in the Yak, we have some definition, which are the keywords which are used in the Yak definition section. The percentage start, as I told you already, this is used to specify what is the first non-terminal symbol, the start symbol in the grammar. So when you start with the grammar, what is the first non-terminal symbol that is mentioned by means of percentage start. And we have percentage union. What is the use of percentage union is when you want to keep a collection of data types. So you want to use different data types. That time we can go ahead with the percentage union. So it will be having different values. In percentage token, it is used to define the token. So it says that it is declaring a terminal symbol with no precedence or associativity specified. So we are keeping the tokens over there. What are the tokens which is written from the lex? Those tokens we can define in the Yak file. Then percentage type, it will be declaring the type of the value for the non-terminal symbol. So what's the type we want to declare? That for the non-terminal symbol, you can use the percentage type. And what is percentage right is? Percentage right is used to define the terminal symbol which we use in our grammar. So what whether it is a right to left associativity or not, that will be decided by this. So the percentage right, so when you keep the values, I mean the symbols over there, so that will be right to left associativity. And when you have the percentage left, which is used to declare a symbol, so that is left associative. So the percentage left we have used in the previous example also, wherein the plus symbol, minus symbol, and multiplication symbol, division symbol, for which we have used. So whenever there is the token which is present in the RHS of the rule, so which associativity rule needs to be followed when based on the expressions which is given there, based on which the left to right associativity rule will be applied when there is a percentage left. And what is non-associative? I already told you that some of the terminals we need not follow the associativity rule, especially in terms of the unary minus. So we don't need to use the non-associativity rule for the unary minus. So that will be having the highest precedence. So in such case, we use the percentage non-associativity. So these are the some of the the token definitions, the Yacc definitions, which needs to be used in the Yacc program. So the Yacc commands when you are using, so the Yacc tools will be in the different versions. So we have from the AT&T, we have the Yacc, which uses Yacc-D. When you create the C file from the Yacc, so you have the Yacc-D. Similarly, from GNU, we have other version, that is Bison. When you use the Bison, we have the different options which is used with the Yacc program. So based on the vendors, we can use different types versions of the Yacc commands. So this is another important concept you should know overall about the Yacc. So rules may be recursive, rules may be ambiguous. So shift and reduce, how it is to be done. And then Yacc cannot look ahead more than one token. That is what I have already told you, that Yacc cannot look ahead for more than one token. It will be always in the definition of the Yacc also, I have told you that within bracket 1, so which is meant for one token. So that is what exactly is mentioned in this. So in the next session, I'll be giving a few programs from the legs.